and it comes down about this far, then they'll loop a piece, down, loop a piece, and then they're kept straight like this. And the way that some of the people at these factories are able to wire parts, the creativity they have, can only come from experience.
Yeah.
Only from experience. It's crazy. They're so talented. Because also as you get into bigger pieces, you have to start to understand what is a high current density area and what's a low current density area. So for example, a high current density area is a sharp corner. So like the edges on this bracelet are high current density areas.
Okay.
Those areas are going to attract the metal first.
Okay.
Low current density areas would be an area, for example, like if you had a cup, the bottom area inside, or if you had a dome, the bottom of that dome.
Oh, wow.
So there's no edge there. So it's harder for the metal to get there. So as you plate more difficult pieces with a lot of difference in high current and low current density areas, you have to pay attention to the position of the anode, how you wire the part. You also have to pay attention so that you're not dragging a bunch of material.
Oh, okay.
So for example, we just did a big project for Zippo lighters, and we had to be really careful how we fixtured their parts, because if not, that lighter would carry that much solution into the rinse and on through the process. Right. You can see most of the oxidation on the that was on the what we think might be silver on the ear wire is pretty much gone now.
Yeah.
Over time, you'll get in the habit where you start doing two things at once and can be adjusting this at the time that you're rinsing.
How do plating companies figure out how to cost something out?
Good question. There's a couple ways that it can be done. Ultimately, what they're charging for is the amount of metal they put on the surface and labor.
Yeah.
There's a couple ways to figure that out. The most common way for a big factory is based on surface area.
Okay.
So they know when they get a solution, they know the efficiency of the bath because we tell them in the tech chart. And based off of that, they know for every decimeter squared, they're going to use so much metal. So if they know the surface area of the part, they know how much metal they're putting down.
Okay.
That's one way that they calculate it, most common way. Another way to do it is by weight. So if you take a sample of maybe 100 rings and weigh them before you plate, and then you weigh that same 100 rings after you've completely dried and plated again, then you know, okay, we put down this much metal. That difference is grams of metal.
Okay.
And they'll charge for that metal as well as a manufacturing charge.
Okay.
And it really depends on the industry that you're plating for. Plating for jewelry is high volume, low margin.
Okay.
And you have to be competitive.
Okay.
Plating for aerospace, plating for the government for technical work is low volume, high margin.
Okay.
So it really depends, because a technical piece might take 5 different layers. There might be specifications that have very small tolerance and thickness. So there's a lot of things that play into that. There might be hardness requirements for the final plate,
Yeah.
Conductivity requirements.
Okay.
So it changes. But with jewelry, it's generally really low margin and high volume.
Okay.
But volume could be 200 parts a day, and you might be able to do 100 of those at a time on a rack.
Yeah.
Or it could be the volume is 200 and you have to plate one at a time. So that's why the labor part really comes into it.
Sure.
So if you see inside of these leaves,
Yep.
that cupped area here, that would be considered a low current density area.
Okay. Is there anything to do to fix that, or?
No, I mean, you can just, if you take the voltage up, thus taking the amperage up, you'll do better in the low current density area, but then you're also going to risk burning the high current density area, and you'll get frosted parts. I want to take a look at this one in that low current density area before we go to the next bath to really show you what I mean. So down in that area, you'll see we have plating in there. Odds are the thickness in that area is not as thick as the outer edges of this leaf. And that's okay. It's going to get less wear in that area. But that's considered a low current density area.
Okay.
Back in for 30 seconds. You can do your wiring and your fixtures however you see fit. I like to put a little handle just to grab on here. That's why I have that little tab there, so it's easy for me to grab the part and I don't risk dropping it into the bath.
I gotcha.
For the 2-liter unit, we actually have some fixtures, some racks that are made for that bath. We haven't developed any for the 1-liter yet.
Okay.
That'll look good.
So cool.
Be interesting to play with these parts and do some background antique or some oxidation.
So
Very cool.
when you start doing that kind of stuff, do you do it after it's been plated?
Depends on the oxidation you're using.
Okay.
So for example, if you use something like Black Max,
Yeah.
Black Max will come off as soon as you hit the degreaser.
Okay.
It'll just rip it all off.
Gotcha.
Even liver of sulfur will struggle with that unless you do that at room temperature.
Okay.
Degrease at room temperature, it'll stay a little better. Liver of sulfur will gray. It won't give that real dark contrast. So you can plate the whole part, and then you can go in with some sort of a black. There's one, I think Rio and Stoller both sell one that's like a paint almost, and then there's a solvent material that you use to wipe it off the high areas, and that would go on after plating.
Okay.
There is another option, and that is a black Sharpie marker.
Oh, wow. Okay.
The black will stay black. It will not plate wherever you put that. As a matter of fact, that's commonly used to mask off areas. So if you wanted to plate this entire leaf, but you wanted to leave for some reason, let's say you had another little design here and you wanted to leave it the copper color, you can put just a Sharpie marker and color it.
Okay.
Go through the whole process. Then when you're done, you can just take like a acetone, or if you don't want to put something like that, you can take a dry erase marker and go over the Sharpie marker, and it'll take it right off.
Oh, okay. So, like in the jewelry industry, if I'm doing a two-tone piece and I'm rhodiuming, a lot of times we use fingernail polish to stop it off.
Yeah.
And then put it in acetone.
Yeah, it's perfect. Also, you can do that. The only reason people will use Sharpies at time is if they really want the detail where they're masking. You can use a thin point Sharpie and you can get really good detail, and it won't come off.
Wow.
And it will not plate there.
Cool.
So,
That is good to know.
Yep.
Do that one last?
Yep, let's do it.
All right.
I think we can do this one together.
What would make you not want to do it together?
If the chain was really long,
Oh, okay.
I might want to wire the chain a little bit.
Okay.
And really it would depend if I didn't think I had enough anode, but we have plenty to do these, no problem.
So would you hook this to the wire from the wire or to the
Yeah,
circle?
I think what we'll do, we probably can use this same part. We'll probably hang it here and then just bring about halfway up the wire so that we get some more contact there.
Okay, cool.
Just like that. We'll do that same thing here. Go here. like that. So that just gives us an extra contact point for those links,
Okay.
and that should be enough. Go back to our 7 volts. I expect this one to probably be around 5.
This ain't your first rodeo.
I've done it a lot. It's funny because it also depends not just the size of the part, but if for some reason your mixture of your solution wasn't right, you'll have a variation in the amperage too. But the best thing to pay attention to for the degreaser is the powder, or the foam.
Okay.
But I really don't know enough about the one you're using to know what voltage to be at,
Sure.
how long to be,
Okay.
what the action will be in that one. I'm really not sure.
Because this is, you say this is a dry?
Yeah, so you get it in a powder form
Okay.
and mix it with DI or distilled water.
Okay. And
The one you have is liquid.
yeah, I'm not sure what it is. This is technically a hazardous material?
It is.
Okay.
We sell it in a 1 kilo container. We're right now exploring, can we package it in a different form to make it non-haz?
Okay.
I suspect that if we package it in something like a 50-gram pouch, which is generally to make 1 liter of solution, that we would be under the haz regulations.
Okay.
So we're talking about that right now.
Okay.
Also, it would make replenishing the bath easy,
Yeah.
or making the bath.
Yeah.
All somebody knows is for every liter, I use one of these pouches, cut it and dump it in there.
Gotcha. And you might have said, but when do you know you need to change that?
It'll start to, one thing, it'll start to turn dark,
Okay.
but also you'll start to get some buildup. It's like a white, crusty buildup that you'll get on the connection points and stuff.
Okay. And is that,
I change it. Big factories change their degreaser either once a day or once every other day
wow, okay,
because they know how important it is.
that is,
In this size setup, I would probably change yours once a week.
okay,
The beginning of every week, on Monday or Friday before you leave, change it.
okay.
There's going to be times that somebody's going to forget to change the voltage.
Yep.
They're going to forget to go to rinse. They're going to go straight from here to, it's going to happen. But they'll get it. I would recommend having a shutdown process documented and in place. And probably once you know exactly what your sequence is going to be, which I'm assuming is going to be similar,
Yep.
put some numbers on these.
Okay.
So they know number 1, number 2, number 3, or put a chart up behind that
Okay.
shows. I think Jeremy's emailing you our chart if Joe hasn't already sent it to you. We have one, a sequencing chart
Cool.
that's ready.
All right.
You can take it and just put it up there. With your gold solutions, you have a couple options for anodes. I prefer platinized titanium for sure. Some people do use stainless steel. They're cheaper, but I feel like the efficiency of the bath is not the same.
Okay.
Also, color consistency is not the same.
So, growing up, my dad, my grandfather, my dad, they always used a pure gold. anode in
Sure,
there.
you can do that.
Okay.
Yeah.
And then in the rhodium, we had a strip of platinum in there
Mhm.
for the anode.
Yeah, you can do that, and what you're doing there is you're telling basically the bath is not using only the metal that's concentrated in the bath. It's taking that metal soluble through the bath in that anode and depositing it also. Same thing we do with the silver bath now. So silver baths, you have to have silver anodes. Well, you can use a stainless steel anode, but then you're going to use all the silver up out of the silver cyanide.
Okay. Okay.
and you're going to have a hard time building any kind of thickness.
Gotcha.
So with a silver bath, we put a silver anode on purpose so that it'll be soluble to the part as well as the silver cyanide that's in the bath.
Okay.
So same thing. You could always use a piece of gold. You
Yeah.
could always, in a gold bath, you could always use platinum, even in a rhodium bath, because you're not titling down, you're
Right.
titling up.
Okay.
So, but from a cost standpoint, it's much better to use platinized titanium.
Gotcha.
And platinized titanium will generally work across pretty much every solution, but there's no reason here. Just
Yeah.
use stainless steel.
Okay.
If your voltage is off by, 2.9, 3.1, it's not a big deal.
Okay.
It's not going to change the amperage much to affect the plate.
So on your amps over here now, are these dials wide open?
Yeah, wide
Okay.
open. There's, like I said, there's very few baths that you want to manage with amperage
Okay.
in this scale of
Gotcha.
plating.
Yeah.
When you get to big baths here, it's something completely different.
Okay.
But in this scale, really palladium and some eco silver baths you would want to control through amperage.
Okay.
Wire's plated good.
That's cool.
Looks like we batted 1,000.
I know. That's great.
Yeah, really good. I really like this color on these parts.